This is my Lab 5 for ENME351. Here we have the MATLAB simulation in which there are two different RC circuits simulated, one with a 10k ohm resistor and one with a 100k ohm resistor. The one with the 100k ohm resistor has a much slower charge rate due to the higher resistance. For part 2 of the lab, I have my Arduino code here. As you can see, I have the pin modes declared as output and input, as well as a delay with the pin written to low so as to release the charge on the capacitor. I then begin at the correct baud, and in my loop function, I have two for loops, each one to keep track of the appropriate amount of time. The pin should be written to either high or low. I also up here declare my tau variable. I just set it to 1. Yeah, so I have a high and low for loop. In each of those, I'm determining what Vn and Vc are through when it's written high, Vn is going to be 1, and Vc is going to be the read in on that analog pin. Then I print both of these out, separated by a tab, and have the appropriate delay. Then in my processing code, I added code at the beginning to make sure that it reads the correct port and at the correct baud rate, as you can see on this line 14. Additionally, I created some lines with some text and a legend, and I can show you that. Takes a little while to load, but there's that. And down. For my MATLAB analysis code, I got the appropriate option, as well as I just did some math to convert the input and read voltages from in units up to 512, just in terms of volts, so 0 to 5. Additionally, this here is not right. This here is my 100 kilo ohm resistor. And if I switch over A real quick, and run it, this is my 10 kilo ohm resistor. As you can see, it's much closer, a lot less curvature, and time to charge fully. For the final part of the lab, I hooked up my thermistor as a voltage divider, connected to the 5 volts and ground on the Arduino, along with a 10k ohm resistor, which is what I found using the datasheet. In addition, when I cool down the thermistor, it decreases the red constant. I don't have a great way to cool it down, so it's not a very significant change. And then when I heat up the thermistor, it's a noticeable step down in the measured voltage across that resistor, meaning that overall it has a lower resistance. In addition, I believe the time response is just 0 because the capacitor is not a part of the system, as it's just a simple voltage divider. And so the time response would be 0. And I believe that this is behaving as intended because as the resistance changes in the thermistor, the amount of voltage dissipated by the first resistor will be greater or less based on which direction it's changing.